All right, indicator 13. We are covering day 1 and day 2. So in your notes, I want you to start out with a heading, 13.1 or indicator 13 day 1, however you want, but I want you to separate it in your notes because you're going to have both days in your notes today. Okay? All right, so I want to use our example or our jump start is just a little bit of an introduction into system of equations. So I don't need this work part, I just need the graph. So I told you on your jump start to graph both lines on one graph, okay? The reason I wanted you to do that is because that is by definition what a system of equations is, okay? So a system of equations is graphing two equations or more on the same coordinate plane, okay? So let me unlock this here. So if you look at our jump start, right, we had a blue line and an orange line. We graphed them both on the same coordinate plane, and the solution is the point where they cross, okay? So we're going to be talking about two different things. We're going to be talking about system of equations, and from here on out, I call those SOE. And we're going to be dealing with system of, it should be equations, for plural, because you have more than one on a graph. System of helps if I spell it right. Inequalities. And I usually abbreviate that SOI. Okay? So system of equation, system of inequalities. And this part's important. You want to make sure and get this down. The solution, okay, is where they cross or overlap. And the reason I say or is because cross is system of equations and overlap is system of inequalities. And the reason that it's where they cross, if you think about our jump start, this system of equations, we had two equations, and there is only one point on the entire graph that if I input, and remember a point is an X and a Y coordinate, right? So that one point where they cross is the one point on the whole coordinate plane that if I take that X and Y and I plug it into both the blue and the orange equation, it's going to come out and make a true statement like 2 equals 2 or 5 equals 5, okay? If I pick a point up here on the orange line and I plug in that XY into the orange equation, it would make a true statement like 2 equals 2. But if I take a point on the orange line and I plug it into the blue equation, it's going to come out with something false like 0 equals 2. So the solution, or the one point on the whole graph that makes this system of equations true, is the one point on the graph where they cross, or that point is part of the orange line and the blue line. And when you're talking about inequalities, which we'll get into second half of the period, it's where they overlap, because with inequalities you shade and it's multiple points. So there's an orange or a blue shaded point and an orange shaded point, and it's where those overlap. That is your solution, but we'll get to that here in just a minute, okay? All right, so I want to do some examples. And so we're going to start out by doing this example. So you're going to give yourself kind of a rough graph on your notes. I'll give you a minute to sketch that out. Don't get too particular. Just give yourself a graph. Yeah. Oh, absolutely. Just move up to that blank spot. All right, so we have two equations, and we've got a red one that we're going to graph, and then a purple one that we're going to graph. Well, red and purple don't really stand out, do they? All right. Let's see if blue works better. A little bit better. All right. So the first one we're going to graph it in red. So we always start at the y-intercept. So on the y-axis at the 2, the positive 2, I'm going to put my beginning point. Then I'm going to use my slope, which in this case is the 1/2, to move from that 2. So I'm going to go up 1 over 2. And remember, I can also go down 1 and backward 2. And both of those moves, right, 2 negatives make a positive. So both of those moves keep me on that same line. And then I'm going to connect my points with a straight line. Cami does not like diagonal lines, so it kind of gets wonky there, but that's okay. Then I'm going to do the same thing with my second equation. I'm going to start at -1, which is my y-intercept. And I'm going to go down 1 and positive 1, or I can go up 1 and backwards 1. And I want to show you, when you're doing the slope for your second line, keep going on your slope toward the red line. So this was my original point, right? This was my y-intercept. And then I went up 1, backwards 1. And if I go up 1 and backwards 1 again, right, I want to do that because I want to get to the point where I've got my lines crossing. And you want to be very specific and use your slope to make your lines cross, and don't count on your ability to draw straight lines, because straight lines aren't always straight, and you need to be precise here because it's precisely the point where they cross that's your answer. So I'm going to draw this line using all my points that I put on there. And I know technically you only need 2 points to draw a line, but in this case with systems, precision counts, so you really want to keep going on your slope until you really know exactly where they cross. And the reason is because this right here is not your answer. This is the work to get to your answer. Your actual answer is an ordered pair with an x and a y, and it is the one point on the graph where they cross, which in this case is right there. And that point, or that coordinate, is -2, +1. Okay, that right there is what you square or circle or whatever as your answer. The graphing and the figuring out where they crisscross, that's just your work. Okay? All right, so let's look at another example here. We'll do this one. Give you a minute to get that one drawn in your notes. Point 1 or 13. 13.1 or 13 big one. I don't care. Just make sure that's in your notes somewhere. All right, so a couple things come into play here. First of all, you have to remember how to graph those special lines like x equals and y equals. Remember, those are your horizontal and your vertical lines. So first, let's graph our x equals -4. Well, x equals -4 means on the x-axis, I'm going to put a point at -4. And this particular equation does not have a y, so it will never, ever go over by the y. So it stays straight up and down, or is a vertical line. And you want to do on systems, you want your lines, and it'll come into play more so when we get to inequalities, but you want your lines to stretch the whole width of the graph. So don't do like little wimpy lines, right? Don't do a little line like this. That will not serve you well on this assignment, okay? All right, so then next we want to graph our second equation. And here's our second equation, and our y-intercept is -1. So I'm going to go to the y-axis, and I'm going to put a point at -1. And then my slope is up 1 over 2. Well, it's a positive slope, right? So it's up 1, positive 2, up 1, positive 2. But that doesn't really help me because that's not taking me toward my other line. And I need to go toward my other line because I want to know where they cross. So negative or a positive positive, I could also do a negative negative. And that still works. So I could go down 1, backwards 2, down 1, backwards 2. Now I've got what I need. I've got them crossing. So now I'm going to draw that blue line. And because I've used my slope to be very precise, I know exactly where they cross, which is this point right here. And so again, your answer is not this. If you just leave it like this, it's incomplete. It's not right. Your answer is the ordered pair where they cross. And my ordered pair here is -4, -3. That's that black point. -4, -3 is the black point, and that's the point where they cross. Now, what this means is that I can take this information, because that is the solution to this system. That means if I take -4 and -3 for the, remember this is an x and a y, and I plug those into both of these equations, I should get 2 true statements. So if I take for the x, if I plug in a -4, I get -4 equals -4. That's a true statement, correct? So we know it works for the first one. Now if I take it and plug it into my second one, for my y, if I plug a -3 in, and I get 1/2 times -4 minus 1, okay? -3 equals 1/2 of -4 is -2 minus 1, and then -2 minus 1 is -3. -3 equals -3. I get another true statement. So that one point on the graph is the only point on the whole system that if I plug it into both equations, I get a true statement. If I picked a point that was up here on the red line and I plugged it in, it would only make the red one true, but it wouldn't make the blue one true. And if I picked a point over here on the blue line, it would make the blue one true, but not the red one. And I want the one point that makes them both true. Okay, and that's the one point right there where they intersect. All right. So again, this is where, right, learning or knowing how to graph linear equations, which is something we kind of hammered for over a month, several months ago, it keeps coming back. Knowing how to graph it in y equals mx plus b, knowing how to graph those special cases of y equals or x equals, and then also remembering how to, get an example of it. Okay, how to graph one like this. Well, the first one is pretty straightforward. It's just a x equals 4. So I'm going to go to the x-axis, and I'm going to put a point at 4. And because it doesn't have a y, it's never going to go over by the y, so it's just going to go straight up and down. And then I'll wait a second because I know you guys are trying to copy this work down, so I'll wait before I go much further here. All right, so we've graphed the first one, x equals 4. That's pretty straightforward. There's just an x. It only crosses the x-axis. So for the second one, right, it's not really in a graphable form right now. It's in standard form, and we need to move some things around to get it in graphable form, which is like our jump start. So I'm going to minus x and minus x from both sides. And that leaves me -4y equals, now that minus a and minus x, I can't combine those. They're not like terms, so I just write them out separately. So minus x and minus a, and remember I always do the x first because I want it in y equals mx plus b when I'm done, which means your x has to come before your whole number. I need to divide by a -4, and when I divide by a -4, all three get that division by a -4. So the -4 and -4 cancel out, leaving me a y. Now this is something I really want to hammer home because I usually get a lot of people saying the reducing this right here is 4x. It is not. The 4 is on the bottom. What's really between that negative sign and that x that's not there? A 1. If it helps you, put it there, okay? It's a 1. So a 1 is on top of your slope, not a 4. The 4 is on the bottom. Now, two negatives do make a positive, so your slope becomes positive 1/4 x. X is not part of your slope. Sorry, your slope is 1/4. Then the x, and then -8 and -4 is a positive 2. So do not miss, if you just have a negative x, don't miss that there's a 1 there. And I think it helps to actually put it there so that you don't forget that there is a 1 on top and the 4 stays on bottom. Now that's graphable. Now I'm ready. So now I'm going to put my y-intercept at positive 2. And then I'm going to use my slope up 1 over 4. Up 1 over 4 puts me right there. Well, I'm good because I'm already where they're intersecting, so I don't really need more. If I needed to go the other way, I could do negative, negative. So I could go down 1 and backwards 1, 2, 3, 4, and that would put me here. Still on the same line, so that works. But I don't necessarily need it because my first move got me to where I needed, which is that intersection point. So now I'm going to connect my points, to draw my line. And then my solution or my answer is to come back and actually name the ordered pair of where they intersect. And here the ordered pair is 4, 3. Over to 4, up to 3. And that is the answer to this solution, or to this system of equations. That is the one point where they overlap. Okay? Any questions on these? Okay, if they're already in y equals mx plus b, you just graph them. If it's x equals or y equals, those are your horizontal and vertical. And then if they're in standard form, you need to do the move-in and groove-in to get it in y equals mx plus b so that it's graphable. Any question on that? All right, in your notes, go ahead and go to 13.2 or indicator 13, day 2, whichever you want to call it. Oh, whoops, I needed to real quick. Sorry. I do want to actually add something to your 13 indicator 13.1 notes. Sorry. And I don't have an example, so I'm just going to make one here. If you have a system, you need to put this in your notes, okay? This is important. If I have y equals 1/2 x plus 3 and y equals 1/2 x minus 3, okay? If I graph these, I go up to positive 3 and I put a point right here, and I go up 1 over 2. Okay, there's that line. Now I go and I graph this one at negative 3, up 1 over 2, and I draw this line. Where do they cross? They're never going to. They're parallel. So the answer that you write, remember, because you always go back and actually answer it. Your graph is not your answer. Your answer is no solution. And no solutions only come into play. What do you notice is the exact on these? The slope. Yes. If you have identical slopes, okay, they're going to go up 1 over 1, up or up 2 over whatever. They're going to do the same rate of movement. They're never going to cross. So if you have the same slope but different intercepts, it's going to be no solution. Okay? What if you have those are identical, right? So when you graph one, it's going to be like this. And then you graph the second one, and it's also going to be like this. Your answer is infinite because there's a bazillion points where they touch, right? Or they cross because they're the same line. So if you have matching slopes, your option is either infinite or no solution. And that only comes into play if you have identical slopes. If you don't have identical slopes, they will have a single 1-point solution every time. There's never an exception to that. If they have different slopes, you will always have a single 1 solution answer. If they have matching slopes, you're either going to have no solution or infinite. Okay? All right. Now, let's go back to our system of inequalities because that comes into play here as well. To those notes. Where are they at? Here we go. All right, so now let's look at, I want to skip that first one. I want to look at this one. We're doing number 2 here. Copy that down in your notes. This is 13.2 now. So now these are all inequalities, and you know that because instead of an equal sign, there's a greater than or less than sign. All right, so first things first, we're going to graph them one at a time. And I like to color code these. Now, 2 things. One is I have a paper copy for everybody that's in class. Everybody at home has to do it on Cami. I like doing these with colored pencils, and I always do my examples using color. If color doesn't help you, or if it makes it too confusing, or it doesn't make it easier for you, just use your pencil, and I'll show you how to do that as well. But you're going to graph 2 of them, you're going to shade 2 of them, and then your solution, remember back to where we first started our notes, the solution to system of inequalities is where there's overlap. So I'm going to do this first one here in red. And so it's already in y equals mx plus b. So I'm going to go down to -3, and I'm going to put my beginning point. And then my slope is up 1 over 3. Okay, or I could go down 1 and backwards 3. That works too. 2 negatives make a positive. Now, is this going to be a dashed or a solid line? Remember, with inequalities, there's a couple different things you have to do once you get your points on there. Dashed or solid? Solid. So I'm going to connect my points with a solid line. Go all the way across your graph. It will serve you well here, I promise. No chintzy lines. Now I have to shade this. Okay, so I shade. I go back and I put my point on my starting y-intercept, right? And then I look at my equation, and it's all y's greater than that. Well, the y's that are greater than -3 are these y's up here. Oops, it's not going to let me do it. The highlighter just does not work very well here with this. Well, let's just go back to the pen. So the y's that are greater than my y-intercept are these. And so that means for the first equation, I'm going to very lightly, if you do this with a pencil or with colored pencils, be light here. It will save you. I promise it will help you. So I'm going to very lightly shade the red. It's kind of hard to do light with Cami colors, but that's okay. Now I'm going to do my second equation in a different color, if colors help you. And I'm going to put my point, my beginning point at +2. And then my slope is -4/3. So I'm going to drop 1, 2, 3, 4 and go over 3. So 1, 2, 3, 4 over 3. That's there. Is this one going to be dashed or solid? Dashed. And remember, go all the way across your whole graph, all the way out. Now for this one, I'm going to put my point right back at that +2, and then I'm going to look at my equation, and it's all y's greater than that, which that's these. and they're trapped up above. So I'm going to come in here and I'm going to shade up above the whole blue line. Now, this is where your answer comes in, okay? Your answer, if you'll notice, your 4 kind of sectors here that you've got on the graph. You've got a section that's white that has nothing. You have a section that has just red. You have a section that has just blue. And then you have that kind of that weird triangle section that's blue and red. This is your solution area. From here and here, this area right here is your solution area. So instead of giving me a one ordered pair, because these are inequalities, you're going to give me a section of the graph that checks off both. So what that means is if I select a point, say right here, and I put that point in both of my equations, I'm going to get a true statement like 2 is greater than 0. Okay? If I select a point that's just in the red shaded area, it would make my red equation true, but not my blue. If I select a point in this little bitty section down here that's just blue, it would make my blue one true, but not my red one. If I selected a point like right here in the white section, it wouldn't make either one of them true. So when you have different slopes, and I'll tell you about the special cases with matching slopes with these too, but when you have different slopes, your graph should be bisected into 4 triangled sections. A plain white section, a red section or a section that only makes one true, a blue section or a section that only makes the other one true, and then you should have a section where both the red and the blue overlap, and in that triangle, that's your solution set. Yes. Yes. So to answer these using either colored pencils or regular lead, you're going to shade one really light, you're going to shade the other one really light, and then you're either going to take a third colored pencil or your pencil, and you're going to go back over this solution area with a darker press of your pencil or a darker color of colored pencils or something to indicate that you realize that this section right here, oops, kind of killed my arrow. This section right here is your answer. Just like when we had system of equations, our answer was a ordered pair, an x and a y coordinate, and that was your answer. In system of inequalities, your answer is going back and indicating your darker shaded area as your solution area. Okay? So, excuse me. So let's look at one like this. If you'll notice here, your slopes are the same. Well, just like with system of equations, when your slopes are the same, you kind of get a little bit more unique answer. So let's graph them both really quickly. So we'll graph the first one here in red, okay? So I go to -3, I put a point. I go down 1 over 3, or I can go up 1 and backwards 3. Okay, do I do a dashed or a shade or a solid line for number 1? Okay, I'm going to go dashed. So I'm going to come across here with a dashed line, and I'm going to bisect my whole graph, and then I have to decide on shading. Thank you. So I go back to my y-intercept, I put my pencil there, and I look at my graph, and it's all y's less than my pencil. So these are the y's that are less than. So I'm going to very lightly shade this little area, this whole area underneath the line, okay? Then I'm going to take a separate color or my pencil and do it lightly as well, and I'm going to graph the second one. So I'm going to go to +1. Well, if you'll notice, my slope's the same. So I go down 1 over 3, or I go up 1 and backwards 3, dashed or shaded, or solid. Dashed again. Okay, then I'm going to shade. So I'm going to go back here, and I'm going to put my pencil on the point and read it again. All y's less than my pencil. Well, that's these, all right? So I'm going to shade the whole graph underneath that blue. So everything, all of this gets shaded. Now you'll notice, right, this is a special case where I said if your slopes are different, you should have 4 distinct triangles. It's different when the slopes are the same. Just like in equations, it's different. So what should you have? What do I have here? I have a white section that's nothing. I have a just blue section kind of there in the middle. And then with a separate color or with a darker pencil, right, I'm going to come back in where I have blue and red overlap, which is everything under the red. That's my solution area because that's the part of the graph that has both blue and red. So when you have parallel lines, okay, you have three options, and I'm going to cover one of them here in just a second. Actually, I'll do it now since we're already on it. So I'm going to come over here and use a blank one. So with equation or with system of inequalities, yes, I will in just one second. So with system of inequalities, you have three options here. When your slopes are the same, and we already did this, right? When the slopes are the same, we did this with equations, and our options there were no solution and infinite. With inequalities, it's a bit different. We have the one like we just talked about, where you have an orange one that goes this way, and then you have a blue one that also goes this way. And so you have a white, a blue, and an overlap section. And so your overlap section, your overlap section here becomes your solution area. Okay, that's one option when the slopes are the same. The other option is you've got your orange one going this way, and you have the blue one going this way. Where's the overlap? No overlap, right? So the answer here is no solution because there is no overlap. And then your third option is we've got the orange one going this way, and we have the blue one going this way. So your blue goes forever up, your orange goes forever down, right? And then your solution that you would come back in with a darker pencil or with a third color would be between them. Just that area trapped between them, because anything over is just blue and anything under is just orange. And so it's that middle trapped part. So when you have exact slopes with system of inequalities, these are your three special cases. Okay? Any question on the special cases when your slopes are identical with system of inequalities? All right, I'll go back to that other screen now. There you go. All right, one other quick reminder. We're going to do one example like this. Is when you have to do a little bit of work to get it graphable, okay? So what does that look like? I want to use this one here, but I want to do something a little different. So don't write this down just yet, because I want to change this. And I want this one to be y is greater than 2. Okay, those are the two equations I want to use here. All right, so to graph y is greater than 2, on my y-axis, I put a point at 2. And remember, y horizon, is this going to be dashed or solid? Dashed, and it's going to be horizontal. Y horizon goes horizontal, intersect your whole graph. And I'm going to shade above, right? All y is greater than 2, so I'm going to shade everything above 2. Now, my other one is not graphable yet. I have to get it. Oh, shoot, I picked the wrong one. Oh, well. I have to get it graphable. So I'm going to subtract 2x and subtract 2x. And that gives me 3y is less than negative 2x minus 3. Now, I should have picked one that had this example, but right now I'm going to divide by positive 3. What would I do if I were to divide by negative 3? Flip your sign. If you forget to flip your sign when you divide by a negative, you're going to shade the wrong area, okay? So make sure you flip your sign, but here I don't need to because I didn't divide by a negative. So negative 2 over 3 is just negative 2 over 3, x, and then negative 3 and positive 3 is negative 1. So I come down here to this negative 1. I put my first point. Now I'm going to go down 2 over 3, and I'm going away from the red, so I need to get toward the red. So I'm going to go the other way. I'm going to go up to backwards 3, up to backwards 3. That puts me about right there. All right, dashed or solid here? Yep, dashed. And this one is all y's less than, right? Whoops, didn't mean to do that. All y's less than. So that is under here that I shade blue. And this one goes a little off the graph because I kind of made it up. So if I extended this line out a little bit more and shaded above, right? And then my blue was shaded underneath. All right, look at my sections that I have here. I have a section that's just blue, that's right here. I have a section that's just red right here. I have a white section that's neither one of them. And then right up here in this little kind of corner up here, I have a blue and red section. And that's my overlap. And I will tell you on your homework, all of your overlaps fit on the graph. So if you have lines going opposite directions with different slopes, but they don't intersect on the given graph, you've done something wrong, because on your homework, all of them will intersect on your little graph that you're given. Okay? All right, let me give you your homework. If you're at home, you need to do this on Cami and submit to submit your work. And email me if you have any questions.